Hi, I'm Josep Ribes, and in this video I'm going to perform a demo of the MBS system that we have developed at 5G Mag. The system is composed by a 5G core, the MBS broadcast UE and G-Node B, and the MBSTF. Here we have a diagram of the deployment that we're going to use. We deploy all the components in a single virtual machine, and each component is inside its own Docker container. To make debugging easier, we chose to segregate the traffic in two different Linux bridges, in order to have traffic between the UEs and the G-Node Bs apart from the rest of the traffic. The files needed for the deployment are located in a private Git repository, but we plan to make it public in the near future. In this repository, there are instructions to first download all the dependencies, configure some parameters, and then build the Docker images and compile all the software. Okay, so the first demo that we are going to perform is the MBS broadcast demo. In this demo, the objective is to send a video to the UPF in a broadcast session, so it arrives to the UEs. So you only send the video once to the UPF, and every UE that has access to a G-Node B will receive the video. The first step to perform this demo is to create a broadcast session. So we will request the broadcast session to the SMF, and the SMF will configure the UPF and the G-Node Bs. So that they know that they need to forward the traffic to the UEs. Once we have configured the data path, we need to send the video to the UPF. The UPF will forward it to the G-Node Bs via GTP and multicast. Then the G-Node Bs will forward it to the GNU Radio container. This is a special container that will split the traffic to two UEs in this case. Then on the UE, the traffic will come out in a TAN device, and a media player will be able to get the traffic and play the video. Something to notice here is that instead of a physical radio channel, we are using 0MQ in order to emulate it, but all the other radio protocols are implemented. Okay, so the first step will be to restart the system, and now we can see that we have all the containers running. Okay, so the first thing that I'm going to do is to configure the SMF, so it then configures the UPF and the G-Node Bs. So what we requested is a broadcast session, and the traffic is going to be in this multicast group, and it will come from this IP, and this IP is the one from the application function, and this is the response, and it's telling us that it created the session. Okay, now we will start a media player in both UEs, one in the UE1 and the other one in the UE2, and then we can just send the video to the UPF, and the video will be played inside the terminal. As you can see, this is a hack we did in order to play it inside the terminal, but we need to being able to see the video to check that it's being received properly. So instead of playing it here, I'm going to save it. and then send it again, and we're going to wait a few seconds in order to get a part of the video. Okay, now I'm going to get it out of the container, and now I'm going to play it in my local machine, so I can play it in a normal media player. So the video is being downloaded, and now it's playing. And this is the video received in the UIs. Okay, so that's the first part of the demo. Now we're going to perform some of the steps that are available in the MBSTF tutorial from 5G Mag. But instead of testing only the MBSTF, we're going to do an end-to-end demo. So we will actually be able to receive the traffic that the MBSTF is going to produce. Okay. The first thing we're going to try is the pull operation. In this mode, we will ask the MBSTF to request data from an HTTP server. We will request it to get some files from an HTTP server, and then it will forward it to the 5G core, and it will end up being received in the UIs via broadcast. And inside the UI container, we will have a flood receiver that will be able to receive the flood encoded data generated by the MBSTF. And the flood receiver is going to write the files in the file system of the container. Okay, so we're going to restart the system again, so we start with a fresh system. Okay, we're going to run first the flood receiver in the UIs, so it's trying to listen to the traffic, and it will wait for it. So we start it in both UIs. Then we will configure the okay, here we will configure the SMF as we did in the first test we did. Okay, so now the SMF has been configured, and all the data path is configured. Now we're going to send the pull operation request to the MBSTF. And here we can see that we requested 4 files to the MBSTF, and the MBSTF is responding that it's going to perform the operation. And here in both UIs, we see that we have received the 4 files. We can check that the files were received properly. So we're going to get inside the container and in the directory that the files are going to, where the files were saved. And here we can see that we have the 4 files, and we can see the contents of the files. So everything worked properly. Okay, so now instead of only pulling some files, we're going to ask the MBSTF to get a dash video. So in this demo, we're going to ask the MBSTF to get a dash video, and it will forward it to the UIs, and then the flood receiver is going to save the video segments in the file system, and we're going to play it in the terminal like we did in the first test we performed. Okay. So we restart the system again. We're going to start the flood receiver. Here it is. Now we are going to configure the SMF as we did in the last part. Now with this command we are going to create the session for the dash pull operation, and here with this command we are going to activate the pull of the video. So here in the food receiver we see that the data is actually being received by the UI. The init.mp4 is the file with the metadata, and all of the other files, the .m4s, are the actual video segments. Here with this command we can play the video in the terminal, and we see that it's being played properly. Here in the upper part of the terminal you can see that the buffer that the media player contains, well, the buffer that it's internal to the media player, is more or less constant, and that's because the video it's a live stream. So it's the buffer is being filled at the same rate that the video is being played, and that's why we have a constant buffer size. Okay, now instead of playing it in the terminal, I'm going to forward the video to my local PC. So first we need to get it out of the container, and then I will forward it over SSH to my local PC to play the video. So with this command I get it out of the container, and with this command I will forward it to my local PC over SSH. And with this command I'm going to play the video, and this is the video that it's being received by the UIs. So everything has worked properly. Okay, and that would be the end of the demo.